Hi and welcome back to the lab. And today here on the bench we have a Yaesu FT-1000 MP5, I believe, so the field version, and that is really showing some odd behavior, because sometimes when you press PTT and then after your transmission you release a PTT, then suddenly receive is totally gone. And you cannot get receive back until you switch the unit completely off, switch it on again, and then receive is back working. And maybe if you press next time PTT, it is gone again. And additional to that, we found that the PA unit, so the TX unit is getting quite hot. So that is not normal as well, and that all sounds a little bit that there is something wrong with RX-TX switching. So maybe the RX-TX relay or the circuit around. So that all is quite odd, and we really need to investigate what's really going on. So let's start and see what we can do. Okay, and here's our unit, and as you can see, it is already working, and it is receiving. So I'm feeding minus 90 dBm into the radio, and you can hear the tone in the background. And I've tested it before, and for the moment receive is coming back. So we are transmitting with approximately 20 watt output power, and you can hear that receive comes back. But that is what we have seen, that when we press MOX, which is a PTT button, and radio starts to transmit, so of course you can see it here, then you're gonna switch it back to receive, and then suddenly the receive is totally gone, and also here our bars on the S meter are gone, so a clear indication that something was happening. But it is not always reproducible. So now for the moment, as we try to show the problem, it is not there. But there is another issue, that our transmitter is getting really hot. So let's crack open here our housing, and let's go inside, because that is what we need to do anyways. Alright, so lid is off, and here is our PA unit, and I really can tell you that it is quite hot. It is much more hot as it should be, because on receive our PA unit should not really get hot. I mean, it is clear that we start transmitting, that after a while of transmitting it will become hot, but I mean, under standby conditions, without anything to do, if you like, it shouldn't be that hot. Well, I thought let's take the temperature here, and just in this moment our ventilator is switching on, or fan, and that is telling something for its own. But when I go down here to the heat sink, we see that we have 38, 37, and that is now with the fan switched on. Now it is switched off, and I would bet that temperature will immediately go up to over 40 degrees, and that is, of course, as we discussed it already, that is definitely not right. So let me take here our PA unit off, because we need to get access to our RX board, and let's see what we can find. Alright, so and I have now our PA unit out, and what you can see here, so here's our filter board, and we have here our RX TX switching, and here our power supply, not power supply, our power amplifier. Here are our both finals, and well, I believe that somehow our PA board is getting bias voltage to our finals, which only should be there if the radio is switched into transmit. On receive, of course, we should not see any voltage at our basis of our final transistors. So that is what I want to test first. Okay, so you should be able to see everything I do. So our radio is receiving, as you can hear clearly. So I turn it down again so that it will not annoy us. And now I go down to our basis here, where we should see our bias voltage in transmit, of course, not in receive. And our radio is, of course, in receive. So let me go down to our first basis. Yeah, okay, so that is what I've expected. Have a look. So we have 0.6 volt, and we have here also 0.6 volt, and that is clearly the bias voltage, which should not be there. Okay, and that you better understand where I am, here is our PA unit, and let me zoom in a little bit. So what I've done is I've checked here our basis, and the basis of course gets supplied with the bias voltage, and the bias voltage is delivered here over this, oops, you can't see it really, can you? Now, okay, here over this transistor, and you see bias voltage can be adjusted here, and you see that the voltage gets over this transformer to both sides of our transistors, and the transistors gets biased. Now, if we are really looking here to this portion of our circuit, we see that at our connector J6103 we get our transmit voltage, and it is only a little digital transistor which gets pulled to ground, and then our Q6808 gets engaged. And that means, and we can see it when we go over, of course we have, you can't see it, but now, and you see that of course our PA board gets supplied with 13 volt, and if we follow along, we get to exactly this transistor here, all right? And you see under receive condition, this transistor is not pulling our base to ground, which is needed to switch this transistor through. And then under that condition we would have here at our regulator 13 point something at the input, and as it is at 7808 we should see 8 volt at the output. But once again, only if we are in transmit, because we need here our transmit voltage. So why is that important? Of course, if we have bias, something must going on here and brings up a voltage, most likely to our connector J6103. But let's test it. Let's see what we have at our regulator. If we see that we have 13 volt at the input and 8 volt at the output, we definitely know that this is switched, and then we can see what we get here at pin 2 on our 6103, and that is what we are going to do now. Okay, so let's see that we all know where we are. So we have here, down here is our power regulator, and this is input, ground and output. And as we said, we should not see 13 volt or 8 volt because that would tell us that somehow our transmit voltage is there, and we said that our connector 6103, which is 6103, which is this here. So this here is a connector, and at that connector we wouldn't expect any voltage at receive. So let's check that to then make our conclusion on that. Okay, so radio is receiving, and well, let's check. Oh, let me turn it down. So let's check first, because it's the easiest test point. Let's check first what we have on the input, which is here. You see that? That is what I've expected. So we already have our full voltage here on the PA board. And then let me check what we have on the output, which is here, and you see it is 8 volt. So the regulator for itself is working. Now let's see what we have on our transmit voltage line. Okay, so we have 1.5 volt. So that is definitely a little bit too low, but it is obviously enough voltage to let the little digital transistor switch, and therefore our 13.8 volt, so our supply voltage, can get to its regulator, and therefore it is now clear why we have here our bias voltage of approximately 0.65 volt on both sides of our final transistor. And that, of course, is now crisp and clear what it's really going on. And now let's think a little bit about why it could be that way. Okay, and what I already said is that we have here our transmit and receive relay, and of course if I press PTT, we should see here on the wiring, which is finally the wire which is getting here over to our PA board, should show, I believe it is something around 9 volt or so, and should not carry any voltage on receive. So therefore let me go over here to this connector, our transmit voltage, and yes, what we see is our 1.58 volt, which seems to be fairly enough to hold our transmit relay in transmit. And when I now switch, and it is still in receive as we know, and when I now switch it into transmit, which I will do right now, okay, so you see 7.6 volt. So that is how it should be. But when I go back to the receive, we should not see this 1.5 volt any longer, because as you see, this voltage is enough to keep minimum a portion of our circuit into transmit. So therefore we must see where this 1.5 volt is coming from, and I believe that is somewhat a leakage voltage, and we must find where this leakage voltage is coming from. Alright, so what does it all mean? From experience, we know that on the RF board, which is down here, this unit, we have this little receiver protection diode, let me call it that way. And we know that this little diode is very much sensitive against high input power. So if there is a close by station, or it is also sensitive for thunderstorms or what have we. So these little diodes are very often dying if they get a hit in any way. So, and I've now zoomed in here on our RF board, and what you see down here, so that little guy, so that is our receive protection diode, which blows very often. And I already have an idea what it could be. I do not really believe that it is this little diode, because our receiver is working more or less normal, so we do not have a sensitivity problem. So it must be something else. So let's have a look into our schematic. Okay, so that is a schematic of our RF board, and you see we have here our antenna input, if you will, and it goes here through these different relays, which are also the attenuator, which can be switched in, so with this relays here. And finally, if the signal came through all these switching elements, then it finally gets here to our protection diode, which is this here, okay? And you see it is in, let me call it, in the blocking direction. So normally, you know, a diode can be operated in the forward direction, but normally not in reverse. But if we bias a diode, and we need to bias this diode with a voltage which comes here over this coils and what have we, and will then go here to ground. Now this diode is biased, and that means an incoming signal, which is of course, you know, very small, minus 73 dBm, or even lower, down to minus 120 dBm, and therefore an incoming signal can easily go over a biased diode. Okay. On the other hand, we have here the D1055, and that is a diode which really makes me nervous. Simply because if we are following along here this wire, okay, I hope you still see where I am. Now we go down to the junction point, which is here, and what you see, that then, can you see it? Yeah, there you can see it. It is our transmit voltage, which is on this line. Okay, so that means, if my suspicion is right, if for any reason this diode here is leaking, then we get a back feeding of our transmit voltage in receive, okay, and that is something we can easily test. So normally we should see here at the anode, we should see our bias voltage, and of course reduced by 0.7 volt approximately. We should see it here as well, and of course we should see it here at the D1055 as well, but we should not see any voltage in receive, of course, here on the anode side of this diode. And that is what I'm now really interested in. What is about the voltages here on our diodes? And if we have this measures, then we finally can make a further conclusion. Okay, so let's try if I can show it to you, because it is here a little bit critical to get it here into picture. So let me go to our diode. So that here is the anode of our protection diode. So 4 volt, which is normal, I would say. And now on the cathode of that diode, which is here, we have 3.1, which is already a voltage drop of 0.8, a little bit more. So that is maybe already too much, but anyways, could be still fine. But now let's go to this D1055, to the anode, where we should not see anything. So let me move over to that test point. Yeah, here we have it. That is our problem. So we have 2.8 volt, which is here at our diode. So let's go back to our schematic, that you see what I mean. Okay, here you can see it. Here is this diode. Here we have tested 4 volt. Here we have tested 1.5 or so on. And here we had 2 point something. And we should not see any voltage here on the anode, because this diode should be able to block our DC voltage, because the bias, of course, is DC. And if we see voltage here on the anode of this diode, that means that most likely this diode is leaking, because we shouldn't see anything for sure. And that is then clear. We have a back feeding of our transmit voltage. I mean, it is not the right voltage amount, so the level is quite low, but as we have seen, it is obviously enough to engage a little digital transistor. And that is a critical thing. Okay, what could we do? We simply snip off here one side of our diode, so that it definitely can't carry any voltage, any current. And if then our bias voltage is not any longer present at our final transistors, then we know that this diode definitely is our leaking element. Once again, this here is our protection diode, and here this is our D1055, where we think that it is leaking, and as I said, the easiest is to cut it off. And let's see if we can get it here somehow on picture. And of course radio is totally switched off, because otherwise I would damage here something. Now I have cut off here the diode, and I have lifted the diode here a little bit. Let me lift it a little bit more. So that is good, because now it is sure that we do not have any voltage, any contact, of course, any longer. Now let me zoom out, and then let's test. Now I have to switch back on everything, and let me reposition the camera. Okay, so everything is prepared here for testing. So let's start with bias voltage, and let's see what we get. 9.2 millivolt, which is nothing. 9.2 millivolt, that is nothing. Let me check what's about our little 1.5 volt, which we should see here. This is now 0.2 millivolt. Let me see what we have at the input of our voltage regulator, and that is 0.2 volt, so not any longer our 13 volt, and of course then we have at the output 10 millivolt, which is telling me that my suspicion was right. Now we can test here, we can test here the lifted diode, which is hanging in the breeze, and you see that is the side which is hanging in the breeze, shows 0.3 volt. So that means that obviously the diode itself is really toasted, and that diode was causing our problem. But let's test our component tester, what his opinion is. So you see I've connected already the diode, and now let's start here our testing process. Okay, so you see our component tester is reporting a resistor, which means that is not a diode any longer, and that is definitely the proof for that our diode is toasted. So now that means I have to take out here the complete RF board to get finally down to the diode to replace it. So that is quite a lot of work in this old Yaesu radio. I mean, already the power amplifier design, so that is already somewhat funny. Anyway, so next is to take the board out to replace the broken diode. And here a better close-up of our PCB. So let me try to zoom in and then you can see it here much better. And yeah, now let me replace it. Okay, so the new diode is in, and yeah, now we have to put it back into the radio, and let's see how it works out. As you already can see, radio is back receiving, and if we go over to our instrument, need to go a little bit higher to get away the reflection. You see that is really nicely receiving, and we can hear the tone. But more important is if after our repair the voltage leakage is gone. And the easiest way to check it is to go over to our PA unit again. Okay, and again we have our receive. And remember, with receive we had here our 1.5 volt, and you see there is definitely nothing. Then let's go down here to our voltage regulator, and we had at the input the 13 volt, which is now only 0.3, which is fine, and at the output we have almost nothing, which is good, and we had 8 volt before. And what we had our bias voltage, which is now completely gone, if you see. Of course, we have here our 14 volt, so that is the input voltage to our board, so that is entirely fine. And we had here at this pin our 1.5 volt, and that is now 11 millivolt, which is definitely fine. When I now switch it to transmit, we should see here, let me go down there, and can you see it? I hope. We should see our TX voltage, and there we have it, 7.6 volt, very nice. And now we should see at the input of our voltage regulator 13.7, and output 8 volt, and we have our bias voltage now. That is now how it should be. Let me go back here to the voltage of 7.6, because when I now go away from transmit back to receive, and you see only 9.7 millivolt, which is more than fine. And that means radio is definitely fixed. The problem is gone. And yeah, down to the board once again. So you see down there we have our new diode, and you see what a leaking diode can really bring us a lot of trouble. Okay, now of course we have to put back here our PA unit back to the radio. Everything needs to get back in place, and then we are almost ready. Okay, so PA unit is back in, and that means that the radio is completely refinished. Yeah, so the radio is now already running for 10-15 minutes approximately, and my heatsink here is completely cold, so definitely no problem. And yeah, what we can see here is that the radio is receiving, so we hear the tone, I can switch it over to transmit, and it is working, and you here receive his back, so we do not have the problem that we are losing our receive. I mean, that is something we were not able to reproduce. It's the beginning, but I know that the problem was present. But with the new diode, and I mean, we have seen that everything was fine after we have swapped out the diode, so there were no voltage any longer here on our PA unit. That means radio is ready and can go back into operation, and I hope you learned something. Thanks for watching, and catch you next time. Bye.